Hi guys, it's Wednesday. We are halfway through the week, and today we are getting started on what we are actually studying this unit, which is volume. So, what we're going to look at today specifically is going to be some intro information to 3D shapes. So we'll just do some intro. I actually have some 3D shapes in the room today, so after you're done watching the video, you can always come check out those 3D shapes. It might be good to kind of see and touch and feel some of those. And then we will be looking specifically at volume of cylinders today. We will touch on the volume of a lot of the shapes that we talk about today to start, but today specifically we are going to work with cylinders. I put in here anything that is boxed in this green dotted piece should be in your notes. So that's what we're looking for in your notes if you're still a little unclear about what needs to be in your notes. So let's get started. Okay, 3D shapes. So some information about 3D shapes. They have 3 dimensions. So up to this point we've talked about pieces with only 2 dimensions that look something like this or like this. Obviously they only have 2 dimensions. They are flat. They don't have the 3 types, the length, the width, and the height. They just have a length and a width, or a height and a base. Okay, so that's where these are a little different. So a flat surface of a 3D figure is called a face. So if I kind of drew this, I'm not great at drawing some of these, but you can see this would be considered a face. Okay, so with this, and then obviously there would be another face on the other side of that, what we would call a pyramid here. And then an edge is where 2 faces meet. So like right here would be considered the edge of that pyramid. But there would obviously be multiple edges. Okay. So make sure, as you can see, that's boxed off, so write that down. Pause if you need to. Okay, a polyhedron is a 3D figure whose faces are all polygons. Okay, so polygons, if you don't remember, are squares, circles, circles are actually not polygons. Squares, triangles, rectangles, octagons, all of those are polygons. Okay, a vertex of a polyhedron is a point where 3 or more edges meet. So I can't draw a polyhedron very well. So if you want to see what a vertex would be, go up, grab one of the polyhedrons that I brought into the classroom, and you can see where those edges meet. Okay, you're going to see that 3 of them come together to make a point, and that would be a vertex. And then a face is usually what a polyhedron is named after, and that's called our base. So again, make sure to have that written in your notes. Very important. So now we're going to talk about some types of 3D figures that we're going to be looking at. We're going to be looking at the volume of those. So here we go. So the first type that you'll see is a prism, and I have some pictures here. I'm going to move my recorder thing so that you can see it. I have some different types of prisms in here. As you can see, I have a hexagonal prism. It's named off the base. It says that down here. Names are based off the shape of the base. I have a pentagonal prism, so that means there's 5 sides. And a rectangular prism, that means there's 4. So a prism is a polyhedron that has 2 parallel congruent bases. So if you see, the bases of these prisms are the same on either side. So they are parallel and congruent. So they are exactly the same on the sides. The bases can be any polygon, and the other faces are parallelograms. So you can see these parallelograms are just like rectangles essentially, but they're parallel to each other. Okay, so we also have pyramids. Pyramid is a polyhedron that has 1 base. So you can see down here the difference. These have 1 base at the bottom. Okay, they are still named by their base, the shape of the base. So here we have a triangular pyramid because there's a triangle on the bottom. Here we have a square pyramid because there's a square on the bottom, and a hexagonal pyramid because there's a hexagon on the bottom. So they only have 1 base, which is different obviously than prisms. And all of the other faces are triangles. So you see that in the square pyramid here. You see that with the hexagonal pyramid and the triangular pyramid. So you have a bunch of triangles that make up that pyramid. Then we come to items that are not polyhedrons because as I already mentioned, circles are not polygons, okay? So that's why this is not considered a polyhedron. But a cone has one base, okay? Very similar. A cone kind of correlates with pyramids in that it has one base. This base is a circle, okay? And a surface that comes to a point called the vertex. That would be up here, obviously, on our cones. And then we have the item we're going to be looking at today. That is a cylinder, okay? So we're going to be working with cylinders today. Cylinder is a lot like, if we look back at prisms, is that they have two bases. They are circles, though. So, again, not a polyhedron because they are circles. There's no polygon on the bottom. Circle is not a polygon, as we've already talked about. So, cylinder, like a prism, has two parallel congruent bases, but in this case they are circles. And this is what we're going to be looking at today, specifically, is cylinders. Okay. This video is probably going to be a little bit longer because we kind of wanted to go over the basics of 3D figures here and have you get some of that in your notes. But now we're going to look at how to find the volume of those cylinders. We will be looking at how to find the volume of other types of 3D figures moving forward, but today we're going to start with cylinders. So that's the question of the day. How do we find the volume of a cylinder? So if you look at these two cylinders here, just by looking, I want you to think for a second on your own, okay? And think and see, do you think that one of these has a greater volume than the other? Okay, and like it says, I would like you to definitely explain your reasoning if you think one is bigger than the other. Once you've done that, I want you to take a second and think about this. I know we haven't talked about the volume formula yet. Sorry for the disruption. I want you to think about what the volume formula might be and how we might figure those out. Maybe we'll come back to this. Whatever your reasoning was, whatever you think it is, maybe we can come back to this if we have some time. Here is the volume formula for a cylinder. Now, you may be thinking, well, this is the same as the area formula for a parallelogram, okay? False, because this is a little different. Now remember, volume is using three dimensions: height, length, and width. Okay? So when we're looking for the volume of a cylinder, we're actually going to be using the area of the base. Okay? So when you think about this, the area of the base, the area of the base of a cylinder, that's going to be a circle. So really what this B is standing for that it has right here is going to be pi r squared, because that's the area of a circle. From there, we're going to be multiplying that by the height of the cylinder. So while it says V equals B plus H, or sorry, B times H, you're going to have to find the area of that circle. So make sure you also write this piece down as well when you're writing down the volume formula. We're going to do some examples. Okay, first example. We have a volume here, and it tells us to round our answer to the nearest tenth. So if we get started, we're going to follow our formula. And I know some of you are pretty bad about writing down the formula. I want to encourage you heavily to write down the formula. You will not get all your points on your test if you don't have work shown. So what it says is volume equals the area of the base times the height. So really what I'm doing is volume equals pi r squared times the height. So we have pi, which is 3.14. Our radius, which is obvious here, okay, is 3. And we're going to square that. And then our height is, the height of the cylinder is 6. Okay, so we got 3.14, 3 squared, so 3 times 3 is 9 times 6. So now you can multiply in any order. Okay, you could do 9 times 6, maybe you know that, or you could just multiply it on your calculator, 3.14 times 9 times 6, which gives us the volume would be 169.56. It's already to the nearest tenth because that's 2 places after the decimal. We just have to make sure that we label. This is going to be meters, and since we are in 3 dimensions, this is going to be cubed. That's a difference from what we've done so far. Okay, make sure you have this written in your notes. Okay, we're going to try one more together. So this one actually has us solving for something different. There will not be any problems like this on your homework, but it is good to kind of see solving for a different variable. Here we're solving for height. So we have volume equals pi r squared h. And this time it tells us the volume, but we want to know the height. Okay, so this is kind of a unique little example here. So we have 314 as our volume. We're going to plug that in where we see v. 3.14 for pi. R, as you can see, it shows us the whole way across. So that's a diameter. This is equal to our diameter. So our r is going to be half of that. That'll be 5. Okay, so we're going to do 5 squared, and we're looking for the height. So this is a little different, as I said. So we have 314, 3.4 times 5 squared. Well, 5 squared is 25. So 25 times 3.14. I'm doing that off to the side, so that's going to be 78.5. Okay, so this is 25, and we multiplied that by 3.15, so we got 78.5, and we're multiplying that by the height. So what we want to find is the height. So now we're solving an equation. How do I get h alone? Well, h is being multiplied by 78.5, so I'm going to divide. Okay, 314 divided by 78.5 gives me a height of 4 inches. Like I said, you won't see problems like that, but it's still good. I'm not going to be very particular about you writing this one down in your notes. Okay, so this one I want you to try. Okay, so first I want you to find the volume of the jar. So use your formula to find the volume of this jar. Then see if you can find how much salsa would be missing. Okay, would be missing from the jar. All right, that concludes today. So make sure you get your notes checked, and then you can grab your worksheet and you're good to go. Have a great day.